All right, so we are approaching test 2 time pretty quickly here. I just posted on Canvas. Have I mentioned anything about test 2 in here yet or not on the date? Yeah. Okay, so yeah, test 2 will be March 17th, and that's a Thursday. So that's next Thursday. So we've got 2 sections left that we're going to put on test 2, and I don't know if we'll get finished exactly today or not. We'll see. We may have to use part of the class next time to do the second portion. Okay, but we're pretty much going to be finished with material today. Okay. And then that'll give you some prep time there. Again, I'll do a practice test again, just like I did last time. Put that out, and then so a week from today will be review day. We'll review, go through the practice test, and then test 2 will be that next Thursday, okay? March 17th. Okay. All right, so let's take a look at section 2.5. We're a little bit out of order. I just don't really like the order the textbook does stuff. It throws linear functions in kind of a weird spot. So I'm going to put it with the rest of our function stuff that we're going to look at. Okay. So we've already dealt with linear equations, so there's really not a whole lot of new stuff. Really, we just have to kind of refresh our memory on equations of lines, and then we're just thinking about those lines as being functions is all we're adding in. Okay, so as a function, we're thinking about a line as a function. We can write down f of x, and if we want a straight line, sometimes you'll see the notation done like this. Or have f of x equals ax plus b. Okay. That's really not anything new. Okay, we just have different labels. F of x is just the same. Well, let me fix my red pen here. F of x is just the same thing as y. Okay. That's like y. And then a is just like m that we use for slope. Okay. So same thing, still just dealing with a straight line. The number in front of the x is still the slope, and then b is really easy. It's the y-intercept in both. And but just as a function, you'll see it written down like that a lot. Okay. So this number a, when we're thinking about it, this is a function. We would call a the rate of change. But that means the exact same thing as slope. Okay. So slope formula still works, all that kind of thing. And then b is still the y-intercept. That's kind of our notation we use for a linear function. Okay. So anywhere in this assignment you see rate of change, you can think about slope. It's the same thing. And if it asks you how fast a function is changing, it's just whatever the slope is. That same idea. Okay. So we call a function linear but if we can write it in that form, if we can write it in the form that we just saw, f of x equals ax plus b. Then we would say we have a linear function. Okay. Thinking about it graphically or geometrically, that means the graph's going to be a straight line, linear. Looking at the algebraic expression of the function, the important part, okay, when we put it in this form is that we have an exponent of 1 on the x there. That's what makes this thing linear. Okay. One little exception, one that looks a little bit different. So just take note of this one. If a equals 0, then what's our function going to look like? So 0 times x plus some number. We'll just have some number. So if you have a function that is just a number, it's just constant, that's also linear. And so that's something you might not notice. But if we have just f of x equals 7, or just some number, then that's going to be a horizontal line, so that's still linear. Okay. But usually we'll have some number times x plus or minus some other number, and we get a linear function. Okay. So first thing we really want to be able to do is we want to decide if we're dealing with a linear function or not. Okay. Okay. And if it is, we can prove it by writing it in that form, that f of x equals ax plus b form. Okay. So we'll have several of these in the assignment. So the idea is sometimes, depending on how it's written down, it might not look linear, but if we rearrange some things, we can put it in this form and see that it is linear. Or maybe sometimes it'll look like it is linear, but if we actually go to try to put it in this form, then we can't, so it's not really linear. Okay. So let's look at a couple. Okay. So what about that one? Do you think that one's linear? The way we can tell is if we can put it in this ax plus b form, it's linear. If we can't, it's not linear. Okay. So if we're going to try and put it in ax plus b form, maybe you can look at it and tell it's not. This one's not. Okay. But if we go to try to put it in ax plus b form, the first thing we would need to do is we would need to pull this out, multiply it out. X minus 1 squared means x minus 1 times x minus 1. So if we do FOIL there, we get x squared minus x plus 1, or x squared minus 2x plus 1. And there's no way that we can take this thing and write it in ax plus b form because we've got this x squared term in there. Okay. But there's no way we can get rid of that x squared term, so because of that, because of this one is not linear. It's not linear. Put this one. What about that one? What do you think? Think it's linear or not? And you might be able to think ahead. We can go ahead and put it in ax plus b form. Right? If we distribute the 3, we'll get 3x plus 6. So this is in ax plus b form. So this one is linear. Linear. Let's see, what about this? What do you think on that one? This one is linear, but to show it, we've got to put it in ax plus b form. So we've got to do some rewriting here. So the first thing we've got to do, ax plus b form, it's going to be in 2 terms. So we've got to split this up into 2 terms somehow. This is just like the reverse of getting a common denominator. Since x minus 3 is over 4, we can write that as x over 4 minus 3 over 4. That's okay, you just put it both over the denominator. And then that's almost there. That's almost there. This is a 1x. So the other thing we can do, if we have a variable up in the top of a fraction, we can move it over to the side and it means the same thing. So we can write this thing as 1/4 x minus 3 over 4. And then this one is in ax plus b form. Or minus, it's plus and negative. So this one is linear. Questions on those? Okay. Not too bad. This is probably the trickiest thing you'll run into on those. Just remembering how to split the fraction apart. A lot of times that's something people forget. Okay. So our next big goal, and we really brushed on it just a little bit, but our next big goal is if we have a linear function, we want to be able to produce the graph, to make the graph. And we've done that a little bit. So we're going to look at that a little bit more. So here's a linear function. We want to sketch its graph. So a couple ways we can go about this. One way we can do it is we can just find some points that would be on the graph. And the way we do that is we would just pick a few x values. We'll just pick whatever we want for x. And then evaluate our function at those x values. So plug in for x and see what we get out for y. So that's what we could call making a table of values. Some of the problems in WebAssign will say make a table of values and sketch the graph. It's just saying figure out a few points that would be on the graph. And then you can make the graph. So in WebAssign, our graph paper doesn't go too big. I think it goes to like 10 and -10. So we kind of want to pick x values somewhere between there. But other than that, it's your choice. I like picking small numbers because they're easier to work with. So maybe I would do like -1, 0, and 1, something like that. 2 is technically all you need to come up with the graph of a line. Okay. But 3 is safer because if you only do 2 and you mess one of them up, you won't know. But if you do 3 and you have one that doesn't end up on a line with the other 2, then you'll know you made a mistake in there somewhere. Okay. So 3's a good compromise there. So let's see, we want to find f of -1. That means we'll do 2 times -1 minus 3. That'll give us -2 minus 3. That's -5. Get my y out of the way there. Okay. If we use 0, find f of 0, we'll do 2 times 0 minus 3. That's just 0 minus 3, so -3. Okay. And if we do 1, that'll give us 2 minus 3, so -1. Okay. And then we are ready to make our graph. Okay, ready to make our graph. In WebAssign, remember on these, the way you make a graph, and we'll look at the WebAssign screen before we leave, but the way you make a graph for a straight line in WebAssign is that you click on one point that's on the line, and then you click on another point that's on the line, and it draws the line in for you. Okay. So having the 3 points, you can pick 2 of them. So click on whichever one you want to first, and then click on the next one, and it will draw in the line. And what you should do with the third one is make sure that that is also on the graph. Okay. And then you'll know that you're in good shape. And so putting this one in, let's see, we've got the point -1, -5. So I'm going to go to the left 1 and down 5. 1, 2, 3, 4, 5. At the point 0, -3. So down 3, 1, 2, 3. And then the point 1, -1. That point right there. And I forgot my ruler again, but let's see how good we can do. Oh, that's bad. Okay. Something like that. Okay. There's our graph. There's our graph. Okay. Something else that WebAssign will ask you on these is it might say, what's the slope? Okay. We could take 2 of our points that we figured out and use the slope formula. But since we've already got the graph, we don't have to work that hard. What we can do is we can just count the slope off the graph. Right? So like I'm looking if I'm at this point right here on the y-axis. Right? Then to get to the next point, I'd have to go up 2, so positive 2, and to the right 1, so positive 1. So 2 over 1, slope would be 2. Questions on that one? Yeah. Another way we can be given a linear function is as a table of values. So it might just give us the table instead of giving us the actual function rule. And in that case, it usually labels it x and f of x. But don't let that confuse you. F of x is the same thing as y. So let's look at this one. So this table is telling me I've got the point 0, 3, 2, 6, 4, 9, 6, 12 on my graph. And this particular problem, the first thing it's going to tell me to do is it's going to tell me to find the rate of change of f. Ooh. Okay. Rate of change. Remember, the rate of change is just the same thing as the slope. Okay, so when you see rate of change, same thing as slope. Okay. And since we don't have a graph on this one, you could make a graph and then count the slope off. But by the time you do that, it's probably easier just to use the slope formula. So here's the slope formula again. Okay. So if we're going to find the rate of change or the slope of this function, what point should we use, right? So each one of these is a point on the graph. We can pick any two that we want. It's probably a good habit to label them 1 and 2, okay, whichever two you pick, so that you don't get them switched in the middle of the problem. And then remember, f of x is the same thing as y, so here y2, I'm going to have 6. Minus y1, so 3, over x2, which is 2, minus x1, which is 0. There we get 3 over 2, and that's our rate of change or slope. Just plugging into the slope formula there. Stuff similar to what we've already done, it's just kind of in different terminology. Okay. And then the next thing we would want here is we would want to write down the function. Nope. And so we want to write our function in ax plus b form, or it's just like y equals mx plus b form. Okay. So the one part we already have, we've got the rate of change. So this thing is A. The slope is just A. So that's that part. The other part we need the y-intercept. They're kind of nice on all these problems in WebAssign. The y-intercept is one of the points on the list. Which one's our y-intercept? Yeah, so this point, 0, 3, that's our y-intercept. Our y-intercept, the B part would be 3. Now the y-intercept means it's where it crosses the y-axis. So when it crosses the y-axis, the x coordinate is going to be 0. And so this is our y-intercept. So if we want to write down the equation, we already have the slope or the rate of change, so our function for this one would be 3 over 2x plus 3. That's all. So we have to find the slope or the rate of change, and then figure out which point on the list is our y-intercept. It's the one where our x coordinate is 0, and then we can plug in. If they were not nice enough to give us the y-intercept on the list, we could still figure out the equation. We would just have to use that point slope form of a line we dealt with some other point. We could get there. Luckily, we don't have to work that hard on these. Questions on that one? Hanging in there? Best you can? I know it's a rainy day. That's not a good day to try to focus in math class. Okay. So one more way we need to deal with these. Okay. One more way. That's if they just give us a graph. Okay. Let's see. Oop. I'm going to try to draw it better. Okay. A little better. So here's a graph of a function. Okay. One thing you might ask us is to find the rate of change. Okay. Just remember that's the same thing as the slope. All we need to do is we need to find a couple of points on our graph, and then we can count the slope. Okay, so there's a point on our graph. Maybe here's another point that the line goes through. Okay. You can do with any 2 points where the line crosses right on the corners of the grid. Okay. It doesn't have to be 2 that are right beside each other. Just any 2 will work. Okay. So counting the slope, I'm going to start at the point on the y-axis here. So I'm going down 2, so -2, and then to the right 2, so +2. So I'm getting -2 over +2. Okay. So what's that going to end up giving us? We got -2 over +2. That's -1. -1. this one, my slope's -1, or my rate of change. Okay. And then second thing they usually want on these is for us to write down the equation. So it'll say put it in AX plus B form. Okay. So I got my slope, or my rate of change. And so that's A when I plug in. The other thing I need is the y-intercept. What's our y-intercept on this one? It crosses the y-axis right there. So that's 1, 2, 3. So our y-intercept is going to be 3. So plugging into AX plus B form, my function is -1 times x, or negative x, plus 3. So questions on that one? Just really getting familiar with the slope and the y-intercept. They're important. All right. All right, one word problem here. Let me help you with it. Okay, we got a pond, filling it up with water at a rate of 11 gallons per minute. Okay. And we're going to be told that when we started, the pond contains 500 gallons of water. Okay. So part 1 wants us to find a function that models how much water is in the pond at some given time t. Okay. It's going to be linear. It says find a linear function. Okay. And then on this one, it even gives us the name for the function, so we can call it V of t, like the volume of the water for a given time t. So all we need to do is write down the function. Okay. So first thing to look at on this one is how much water do we start with in the pond? 500 gallons, so we're going to start with 500. Okay. And then every time a minute goes by, how many more gallons do we get? We get 11 more gallons every time a minute goes by. So for every minute that passes, we're getting another 11 gallons. And we're adding that to that. So we're going to add 11 gallons times every minute t. Okay. So there's our function. And if we want to write it in AX plus B form, we could say 11t plus 500. Okay. Just switch the order. Okay. All right. Then we got part two. Part two. Part two says something like if the capacity of the pond is let me make a number that comes up good. Hang on 1 second. Math teacher cheat up here. Manipulate it so it comes out not ugly. 1 second. And so capacity of the pond is 1,305 gallons. How long does it take the pond to fill up? So we want to know. So the trickiest thing on this one, okay, time, the thing we're looking for, that's going to be t. That's how many minutes. The trickiest thing on this one is realizing that v of t gives us how much water we have in the pond after a certain amount of time. Yeah. So what amount of water are we trying to get to? Yeah, 1,305 gallons, 1,305 gallons. So what we want to know is we want to know that when v of t is 1,305, how much time's gone by? What's t? So to set this thing up, this number is going to be what we put in where v of t is. So we'll have 1,305 equals 11t plus 500. So this part goes here. What we want to know is how much time's gone by. So we're solving for t. Solving for t. Once you get to here, it's easy. Just realizing where this number goes is the main thing. So how can we solve for t? Okay, we can subtract 500. Yeah. So if we subtract 500 from both sides, and we'll get 605 equals 11t. Okay. Then what? Divide both sides by 11. Yeah. If we do that, 605 divided by 11, we get t is 55, and our units here are minutes. Okay, so it'll take 55 minutes. Okay. Not too long. 11 gallons a minute is pretty quick. Yeah, it sure would. So 805 divided by 11. Thank you. So that one comes out something ugly because so that's like 73.1 minutes. Okay. Sorry, messed my math up trying to pick the numbers. Thanks for catching that, because I was sure that confused somebody, multiple people. All right. Questions? Hanging in there? Yep.
So how do we know what number on the first number?
Yeah, because so V of T is like how many gallons we've got after a certain amount of minutes. So we just know we're trying to get to 1,305 gallons. So that's the number we're trying to get to. So that's the number we put over on the other side. And then we can solve for T's how long it takes to get there. Yep. And then another way, just kind of general thing, we know T is time. So we know 1305 can't go in for T because it's gallons, right? So that'll help too. Okay. Other questions? Okay. You need to stretch for a second? That's the end of that section. Need to stretch or wake up or anything? No? Okay. No. Not real energetic today? No sleepy Tuesday with the rain outside and all that? Yeah, okay. Okay. So, next section, last one that we'll put on test 2. 3.1, still dealing with functions, but we're going to look at quadratic functions. Okay. So we really only had one way that we write linear functions. Quadratic functions, we've got 2 main ways you'll see them written down. Okay. So one way looks like this, and this is one you're probably familiar with. Ax squared plus bx plus c. That goes back to when we talked about quadratic equations. And then another way you'll see these. Sometimes you'll see them written like this. See them written a parenthesis x minus h parenthesis squared plus k. This bottom one, our textbook calls it standard form, but I think most people probably call it vertex form. And we'll talk about why that is in just a minute. Okay. That's two different ways there. Okay. This way, A, B, and C are just like with the quadratic formula that we did. That's kind of our standard form for doing quadratic formula. Okay. This way may look a little bit different. Okay. So with a linear function, the 2 main things we want to know about them, we want to know their slope and we want to know their y-intercept. That's our focus with linear functions, because then if we know slope and y-intercept, we can draw in the graph and figure out everything else we want to know. Okay. With quadratic functions, okay, the key information, if you will, okay. So we have something called the vertex. Okay. And then we also want to know what I'm going to call its opening direction. So with quadratics, we can either have them, they look like a bowl or something like that, right, where it opens upward. We could have them where they look like an umbrella, that open downward. Those are the two things there. Figuring out if it opens up or down, it's not hard. Okay. What we're going to look at for that is we're going to look at the number a, so either the number in front of the x squared if it's in this form, or the number that's in front of the parentheses if it's in this form. Okay. And if you take one written like this and you rewrite it like this, the a number stays the same. Okay, it doesn't change. And so if a is positive, if a is bigger than 0, or positive, then our function is going to, our parabola is going to open upward. And you can remember that because if you're positive, you're smiling. Okay. So parabola opens upward there. It's positive. I made it look weird when I put arrows on it. So. Okay. If that number a is negative, what do you do if you're negative all the time? Frown. Okay. So f of x will open downward. Okay. What about if a is 0? We don't have to worry about it because if a is 0, this whole first term with x squared is 0. We don't have an x squared term anymore. Now we've got a linear function. Okay. So with quadratics, the only choices we have is either a is positive or a is negative. So it either opens up or opens down. Okay. The other key piece of information, the vertex, we're going to spend a little bit more time on. Okay. A little less familiar. We have a quadratic written in that second form. It's pretty easy. If we're written in that second form, the x minus h form, the vertex is at the point h comma k. And we can just read it off the equation. And by the vertex, I haven't mentioned that yet. The vertex is either, if we have a parabola that opens upward, vertex would be the very bottom point. We have a parabola that opens downward, the vertex will be the very top point. Okay. These two would be vertex. So it's either the lowest point on a parabola that opens upward or the highest point on a parabola that opens downward. So you can think about it either the bottom of the valley or the peak of the mountain. The peak of the mountain. Okay. So in that point would be the point h comma k. Okay. One thing to notice is we're subtracting h, and then our vertex has an x coordinate h. Okay, so it's kind of, you have to kind of treat the sign, take the opposite. What's here? The one on the outside, you just keep whatever sign it has. Okay, so this is plus k, I get k. So let's look at one. Let's look at one. There's that one. We got 3 times x minus 2 squared plus 1. It is a quadratic function, and it's in that vertex form, so we can just read the vertex off of there. So plus the x coordinate of our vertex on that one. It's going to be, it says x minus h. So here we got x minus 2, so our x coordinate is going to be 2. And then on the outside we got plus 1, so our y coordinate is going to be 1. If you have one like this, our vertex, where's that one going to be? We're supposed to be subtracting, so we'll have to do minus a negative 7. So our x coordinate is going to be negative 7. And then our y coordinate, what's it going to be? Negative 4, yeah, you just keep the sign there. So you kind of just change the sign of whatever's with the x, and then keep the sign of whatever's on the outside. It's the vertex. Questions there? All right. And so something else to mention. Let's see. So because of the shape of the graphs, every quadratic function either has a maximum or a minimum value. That's not true for linear functions. Right, linear functions, if we just have some line in there, this keeps going up forever, so no maximum. Keeps going down to the left forever, so no minimum. But with quadratics, we do have either a maximum or a minimum. Maximum, I was supposed to say or a minimum value. Okay. We don't have both. We only have one or the other. Okay. Because the two ways they can look, right, we have a parabola that opens upward. Which one will we have? Will we have a maximum or a minimum value? A minimum, yeah, because we can go down at the vertex. And so this would be our minimum value, but this thing goes up forever, so we have no maximum. Okay, so it just keeps going up forever, but we can only go down so far. Or if we have a parabola that opens downward, then we'll have a maximum value, that occurs at the vertex, but it keeps going down for forever, so we would not have a minimum. So the maximum or minimum always occurs at the vertex. That's one reason why the vertex is such an important value. Because if we want to know the maximum value our function takes on or the minimum value our function takes on, whichever one we have, it's always going to happen at the vertex. And what the vertex gives us, okay, the x-coordinate tells us where the minimum or the maximum occurs. And then the y-coordinate gives us the actual minimum or maximum value. And so our x-coordinate is where it happens. Our y-coordinate is what is the minimum or maximum value. Hanging in there? All right. We're doing good. We're doing good. So take a mind break from math for just a second. I'll tell you about, since we're doing so good, we'll tell you about the plans for Thursday then. Okay, so Thursday, we will just work on WebAssign together. Okay, so please, if you're not completely caught up with WebAssign, don't take it as an off day. Take it as a day to come work on WebAssign. Okay, you can work on WebAssign together. I'll be here to help. I can help as much as I can. And you can help each other. Okay? So you can, if you got a laptop, bring a laptop. If you need to just write some problems down, write some problems down. I'll help you with those. However want to do that. Okay? If you've got an old assignment that you need open back up, you want to work on Thursday, request the extension and I'll open it back up. Okay? Make use of our time that way. And then review on Tuesday and test next Thursday. Okay? All right. Okay, let's look at a couple of graphs. We don't have too much left. Let's see. No, I'm gonna do better. Change my mind. Okay. There's a parabola, quadratic function. Okay. And I mean for that to come down here. So question number 1. Where's our vertex? I want it to be this point right here. I'm not the best at drawing on here. Okay. So this is our vertex. Where's what's our coordinates? Have to go over 1, 2, 3, and then down 2. Okay. So our vertex would be at 3, -2. Okay. looking at the graph, what about x-intercepts? So I want it to be crossing right there and right there. Okay. So we want to write these down as points. Okay. So we've got two places where we cross the x-axis. Okay. So we've got the point 1, 0. Okay. 1 x-intercept. And then we got the point 1, 2, 3, 4, 5, 0. Okay. Those would be our x-intercepts. Okay. I meant for this to be crossing right here, so at that point, we would call our y-intercept, and we want to write it down as a point. So our coordinates there would be 0, right? We don't go left or right, and then positive 2, so 0, 2. Okay. So you got some problems that I ask you for those. It'll give you the graph though. You just gotta put the points in off the graph. Okay. Then we want to know, does this function have a maximum or a minimum? Minimum, we have a minimum. Okay, we have a minimum. And the minimum value, what's it going to be? So remember, the actual value is the y-coordinate. So we've already got the vertex picked out. It's 3, -2. So the minimum happens at x equals 3, but our minimum value is -2. -2. Yeah. -2. Okay. That's like number 4 there. Okay. And then one other thing on these, just because it wouldn't let me leave it out. Okay. But it's not too bad because we have the graph. What's the domain and range? Okay, here's something that's nice. The domain for every quadratic function, -infinity to +infinity. Okay. All of them. No thought required. The range, remember those are the y values that we get out of our function. So what's the lowest y value we can get out of our function? We got to go all the way down to -2. So -2 is as small as our y values get. And then how big do they get? Infinity. Yeah, they go forever. Okay. So our domain on this one, we can get to -2, so we'll have a bracket, -2, and then this one goes to infinity. Okay. So the range, if you have a minimum, we'll have a bracket and then the minimum value, and it goes to infinity. If it's turned the other way, you'll go from -infinity at the bottom all the way up to the whatever the maximum value is. Right? So it'll either look like this or it'll be flipped. It'll be flipped. Okay. All right, one last thing. We said if we have a quadratic function written in this form, we can just read the vertex off. Right? It's going to be HK. But what if we have a quadratic formula written in the other form where we have ax squared plus bx plus c form? Okay. If we have that form, and there's two ways you can go about it. Either you can use completing the square to rewrite it into the vertex form. Most people don't want to have to complete the square. So our other option, we've got a formula. And then it says our vertex is going to be at the point negative b over 2a. Once we figure out what that number is, we just take that number and plug it into the function. So f of negative b over 2a. So negative b over 2a tells you where the x-coordinate of the vertex is, and then you plug that into the function. That tells you what the actual minimum or maximum value is in the vertex. Okay. So let's look at a couple. It's not bad. It looks more complicated doing the f of negative b over 2a. That's just f of some number. So let's look at one. So we want to find the vertex. So the first thing we need to figure out what this number negative b over 2a is. So to find that part, so this is our a, this is our b. So if we do negative b, that's going to be 24 over 2 times a, so 2 times 6. That's 24 over 12, which is 2. Okay. So that's negative b over 2a is just 2. So to get, that's the x-coordinate of our vertex. So to get the y-coordinate, we just take this 2 and plug it into our function. In other words, we find f of 2. Oh, not 24 eggs. So let's see. 2 squared is 4. 4 times 6 is 24. Negative 24 times 2 is negative 48. Minus 130. So just crunch the number. On that one, it comes out ugly. Get negative 154. That's okay. So this is going to be my x. This is going to be my y. So my vertex is at the point 2, negative 154. So kind of got a big number for the y-coordinate there, but that's okay. Questions on that one? Okay. Got excited. I thought you were raising your hand back there. You're just stretching. At least you're not snoring. Okay. All right. So one more. Okay. It can be worded a little different. Okay. Okay. So this one says find the minimum or maximum value. This will be our last one. Okay. So anytime we have a minimum or a maximum value, where's that going to happen? At the vertex. It's going to happen at the vertex. So any problem on these where you see minimum or maximum value, that means we need to find the vertex. So I'm going to use this. Okay. So here, what's my A on this one? -1, and then B is -8. We don't care about C. We just need A and B. Okay. So if I do negative B over 2A, it's going to be 8 over 2 times -1. 8 over -2, or -4. If it asked me where the minimum or the maximum occurred, we would be done. But it actually asked for the minimum or maximum value, so we need the y-coordinate of the vertex. So what we'll do is we'll plug our number we got on that last step in. So f of -4 okay. You have to be a little careful with the signs on this one. It's a good idea to put parentheses when you're plugging a number in. Okay. So -4 squared is 16, but we've got a minus sign out in front of that, so -16. -8 times -4 is +32. And then plus 3, so that comes out to 19. And which one is it? Is this a minimum or maximum? Well, we don't have one or the other. So the way we figure that out, we got to think about, is our parabola opening up, where it'll have a minimum, or down, where it'll have a maximum? Remember how to tell? You look at the number in front of the x squared. This one is negative, so it's frowning. So we'll have a maximum. We'll have a maximum, yeah. We'll have a maximum. Have a max here. If our A was positive, it would open up, and we would have a minimum. Okay. All right, that's it. Okay, you're free. Get out of here before it starts raining too hard. Okay.